All right, first things first, I'm going to give you guys some general tips on exams. So this teacher's very nice because she gives you the structure of the exams. She can kind of like reverse engineer, in a way, the solution, because you know which concepts are going to be used for which question. So when she gives you the exam, she's going to tell you, okay, this question is going to be divide and conquer. So you know that you need to apply a divide and conquer algorithm. So what is divide and conquer? Essentially three things. Okay, so we're going to basically split our input into two halves. There's like many different definitions, but I think this one should be sufficient. So I'm going to say two halves, we'll call it L1 and L2. Not necessarily lists, but I'm just going to call it that for this question. And then you should call the function, the one that you're writing, recursively on L1, L2. And then with those outputs of those recursive calls, you want to recombine the results using some other function, right? I would suggest if you really want to like get the basics down, like implement merge sorts. I think that'd be very helpful. Okay. So, this one I'm just gonna show you like how to think about it and how to solve it. And in terms of proving it in time complexity, I think the worksheet's thorough enough and you can just look at that. But in terms of video, what's actually needed, I think it's like actually like coming up with a solution. It's more important for in terms of like making a video. Okay, so how do you think about divide and conquer? Okay, how do you think about divide and conquer? Okay, let's say we have, this is how you have to think about it. Consider you have two halves of the solution, right? You basically have the first half, it returns something. The second half, it returns something. And when you recombine it, then you get a solution for those two halves combined. Let me just write that out. Let's say two halves of the solution. How you want to think about the following. How would we merge the halves? If we were given two halves of the solutions, how would we merge? Right? What information would we need to merge? Right? The information that we need to merge will tell us what we actually need to return, because normally the information is what we return from the recursive call. Okay? So I'm going to say, what info would we need from the two halves? That info is returned. So most of the time, like this half that's being returned is literally the solution to the question if our input was just that half. Okay, so I'll just repeat it. The best tip for divide and conquer is not thinking about like the entire thing, but thinking about, if I had two halves of the solution, how would I merge it? What information would I need? And and answering the question of what information I need will tell you what you need to return. And commonly, it's basically just like the solution, or what the information that you need to return is literally the solution as if the input was just that one half, right? So going to the question, in this case, how you think about it is like, okay, we're given these buildings, or let me just give you like a brief rundown on how we even come up with this output, right? Basically, we want to generate a skyline based on buildings. Okay, so you can kind of like go left to right, like this way, and see we're starting at 0, and we're basically, if you notice, we're basically keeping, or accounting for every point where our height changes, right? So we have this one, and then we have this one. Height changes from 10 to 15 here. Then height changes from 15 to, I think, 12. Yeah, 12. And then height changes from 12 to, I think, here. Yeah. And then height changes from 0 to 10. Height changes again from 10 to whatever this is, probably like 8 or something. And then height changes from 8 to 0. And let's see if that's correct. 210, 315, 712, 12 0, 15 0, or 15 10, 28, and 24 0. Yeah. Okay. And going back to like how you think about divide and conquer is like, okay, we're given this list. If we split it in half and called our function recursively to find the skyline of each half, what information would we need from both halves to recombine it? And it just so happens is if we just have the skyline from each half, we can recombine it and get the skyline of the entire thing. Yeah. So how do you actually do that? Okay, so like I said, based on observation, we go through input linearly, and the question says it's sorted by x coordinate, which is important, the buildings. So we can truly go this way. Okay, so based on observation, go through buildings inputs linearly, recording the point every time height changes. Essentially starting at 0, right? Because like where do we even start? Starting at 0, so then we can include this 210. Okay, so I gave you the first tip about divide and conquer, is jumping straight to thinking about how you would even recombine. Like what two halves do you have to return and how you would recombine those, right? The second most important thing for divide and conquer is rigorously understanding a small example to prove to yourself that the way you're recombining actually works. Okay, so let me define like a small example like this. Say we have this, and so I'm actually going to take this straight from here. I'll just tell you the outputs would be, let's see, let's first draw it. So I'm going to draw how the input looks like, which I recommend you do on the test. Okay, so looks like we have our first building here. 2 to 9. Oh, sorry, no. 2 to 10. Ending at 9. Like this. And then, the second building is 3 to 7. Ending at 15. So like this. And you can see, based on how we applied like the left to right algorithm, right? Go here, change of height, change of height, change of height. Therefore our output is 2, 10, 3, 15, 7, 10, 9, 0. Okay? So the expert note here is rigorously go through a simple test case. Okay, so how would this actually work? So for algorithm to execute on this like small example, let's say this was the inputs, then first we would want to split in half, right? And it's obvious like what the half should be, right? The first half should be this, just like your L1. Your L2 would be the other half. In this case, is the since the n equals 2, our 2 halves would just be n equals 1. Right? And another big important thing of divide and conquer is your base case. And this is our base case, n equals 1. So looking at this one, we have 2, 9, we have 10. Looks like this, right? Okay. How would it look like? Okay. Change of height, change of height. Perfect. Like that. What about for this? It would look like this. Change of height, change of height. So we would be returning 2, 10, 9, 0. We would be turning from here 3, 15, 7, 0. So it's really important to make observations. Like, okay, like I guess you can kind of logic like, okay, this is like, or I mean, you can kind of logic through like how you even place these red points. Sorry, what am I even saying? Okay, you want to make an observation how you're even going to place these red points. The observation is this thing right here. Right? It might be intuitive or it might not be intuitive, but it's really important to really understand how you get from input to outputs. Because if you don't understand how you get to input to output, then you're going to answer the wrong question, which is really bad. Okay. So that means when we called our function on L1 and L2, we got this as our outputs, right? So recursive call from L1. From L2. Okay? So let's see. Let's draw like this together. We have 15 here, we have 10 here. 7, 9. First one looks like this or something. That one looks like this. Okay. This is this one. I'm gonna use different colors to distinguish them. Right. So this is obviously, if we return these points, this is not going to be correct because we haven't done the merge step yet. So how do we merge this? Okay, well, to learn how we merge this, let's actually draw what should the final thing be. It should be this. Let's use purple. How do we get this? Every change of height, right? Boom. Change of height. Change of height, change of height. Okay. Perfect. Change of height, considering like we colored like everything in like that, right? So we wouldn't include this because the building is like, yeah. Okay. Now, what should the output be? Well, I'll just tell you that it's going to be this because that's what I wrote earlier. Okay, but how do we even come up with that? Okay, well, let's look through what we have, which is this, and see how do we get to this. Okay, so looking through this picture, we're going left to right. We know that. And it's guaranteed that when we return from L1 and L2, like these x coordinates will stay left to right because the original thing is sorted. If it wasn't sorted, you should have sorted it beforehand. But the question says it's sorted, which is very helpful. Actually, yeah. Okay. So we need like to keep track of like some results, right? Or I'm not gonna write anything now, but I'll just say, okay, we're gonna be appending to some array or list of some sort these points. So let's say this is the list and we're gonna append this. Okay, so going through left to right, how would we look at this? We add 210. I'm gonna get rid of this because it looks really bad. We add 210. Why? Because we're basically starting like both buildings. You can kind of think about it as you're starting as both buildings being at 0, right? The current height of both buildings are at 0 as you're going left to right. That guarantees, and basically it's guaranteed that the first building you see, you should add that height. So that means we add 210. How do we know that this is the first one we see? Well, we would actually be comparing. We'd have a pointer here and a pointer here, comparing which x value is smaller, because that's the one we would currently be processing. Okay, so since 2 is smaller than 3, we process 2, and we see that our current height is 0 and 0, so we should obviously add this because there's a change in height. Okay, now the next thing we should add is this 3 and 15. Because now our pointer is here, and 9 is greater than 3, so that means we should process 3 first. And we're going to add this 15 because it's a change of height. But what if our thing was actually like, okay, let's say this was, put this as blue. This building was blue. What if it was like here, like it was inside? Obviously, we would not add this 3 blah, blah, blah. But you might ask, isn't there a change of height? Well, I'm talking about the change of height of like the skyline. In this case, there's no change of height of the skyline. Okay. Okay, well, okay, I guess that makes sense. So you're basically saying this 15 is greater than this 10. So we should add this 15. Okay, I guess we can rock with that logic for now, but if it's wrong, we should mitigate it later. Okay, so we add this 315. Let's move this pointer to the right. Okay, now we're looking at 9 and 7. Okay, obviously 7 is first. Okay. Oh, wait. 7's 0. Well, it's over here, right? So we shouldn't add it, right? But we do need to add something because we need to account for this point. So how do we do that? Well, what is this point right here? It's at 10. So it looks like we need to keep track of our current left and right height, like current left building and right height. And like I said in the beginning, we can kind of like, if we're like looking through it like this, you can find, if you don't have a building, you can kind of like assume, okay, we're basically starting at 0 height for the left building and 0 height for the right building. And even if you didn't assume that, when you go through it, it like works out if you just use that. So let's just have a variable, left h 0 and right h 0. Okay, but we want like kind of like a generalizable thing, right? Whether the thing is above or below, we want to make sure that we're either adding it correctly or adding nothing correctly, or not adding, or sorry, we're either adding it correctly or correctly not adding something. Okay? So how do we do that? Well, let's go back to the basics then. if we're looking at this thing right here, right, that means our current right, its height, is at 0. Why? Okay, I'm gonna say this is this red is the right building, and this blue is the left building. Okay, and since we're currently processing this point right here, that means our right height should be 0. And our left height should be what? Well, it should actually be 10. Now, what should we do? Well, it looks like the point that we add will always be the max between these two values. Notice here, at this point right here, this intersection right here, the point that we added was the max between our current left, which was 10, because we added 10 when we were processing this one, and our current right, which at that time was 15, until we visited this one where we had to change it to 0, right? We added the max one between 15 and 10, right? So we added 15. Okay, but what if, like I said before, our actual building was like at 3.5? Then we don't add it, right? Well, let's see how our current algorithm would work if we took the max. Well, if we took the max, we would get 10. And then we would try to add 310. But that doesn't make sense. Why does it make sense? Because there's no change of height. Remember, our Skyline is supposed to record change of heights only, but they're both the same. So we should check for that. We should say, okay, the previous element that we just added, make sure the height is not the same. We only add it if the height is not the same. Okay, so that basically fixes everything for us. Let's go back. Okay. So, going back to this example, right here, our right is now 0, our left is still 10. We have not reached a new left yet, or we haven't processed a new left yet. Okay. If we take the max, which is 10, we see what our current thing is, which is 7, sorry, current x coordinate. So we're saying, okay, we're going to add 710. What is our condition for not adding it? If the previous one is the same height, well, it's not the same height, so we can add it. We add 710. Perfect. So we're done going through here. Pointer is out here. Basically, we're done processing this list. And when we're done processing this list, it's kind of obvious to see that we should just take everything from here. No matter what it is, just take everything until we're done processing this list. So we'll just take 90. And vice versa. Right. If we didn't do that, then we'd try to be comparing something like this nothing value with 9. Okay, so now that we have that, it's still, you probably are still confused. So let's actually go through like a coding example. I'm gonna do this in Python, and even if you don't know Python, I'll walk you through, so you should be fine still. I'm gonna get this straight from Leetcode actually. So we have this function, get Skyline. This is just self, which means like this function is part of a class. In this case, class solution, but I'm not going to write it. Buildings. Sure, I'll just write this too. What this is saying is that it's going to be a list of lists, right? And everyone knows C++, so I'm basically saying it's going to be a vector of vectors, or the inner vectors all have integers. Okay, and then we're going to return a vector of vectors, where each vector is a vector of integers, or in this case, since we're using Python, we're saying list. Okay. First thing, let's obviously have the base case, right? If there's no buildings, I should obviously return nothing. if there's just one building, that's basically our base case. What was our base case? Well, let's look at this again. Given this, we had to transform it to this, right? So we can kind of destructure this as left, right, and height. Okay. Left, right, and height. What we should return is, looks like left, height, and right, 0. Just from how this looks. Okay, we can do that. Let's do that. Left, right, and height. To get this element, if the list is 1, you can just, for sure you can access this, sub-0. And then we're going to return left, height, right, 0. Okay, that's our base case. We basically just finished this part. Perfect. Now, let's do this. Okay, maybe I should write here, step 0 base case. Okay. How do we know how to split in half? Well, let's first calculate this mid value that we should use to index the thing. And that will be the length of buildings currently. Divided by 2. This is integer. This is how you do integer division in Python. You use 2 of them. Okay, so that means let's call this left skyline. And we'll, as we said, we're doing the recursive call on L1 right here. Self.get skyline. And we're going to pass in the left half of the list. And this is just Python, where basically we're going to pass in everything, all the values corresponding to the indexes up, not including mid. Okay. All right, skyline. By the way, if you don't understand anything here, you should search up the syntax. Get skyline. Buildings. I'm thinking back, I probably just wrote pseudocode. But since I already started, I'm just gonna continue. Python is basically pseudocode. Not really. Take that back. Okay. Now the final thing that we should return is the combination of left and right. So we're just gonna say, we're gonna call some function, and that function is gonna take care of it for us. And we're obviously gonna write that function. That function is basically gonna do this logic. We're gonna pass in left, and we're gonna pass in right. Okay. And if you trust that this merges correctly, then we're done. But let's actually write that code. We'll have def merge skylines. That's how you declare a function. Left skyline. Right skyline. Like we said, we're going to create this list of, this output list. Let's just create it results, make it equal to an empty list. And when we're going through each element, we have like a pointer right here, right? And they obviously start at the beginning of each one. So let's call it I and J. And they're both starting at 0. And remember, when we first started, we assumed our both buildings started at 0, and that worked out perfectly for us because we'd guarantee with that we'd add this first thing here. So we have our left H. So what does this represent? Well, it represents the current heights, the left building and the right building and in processing. Okay. First things first, we have a while loop. What is our while loop? It's basically checking to see if we're still like comparing between the left and right half of the lists, or the left list and the right list. Okay, so that means, and like I said before, right, once we finish processing one list, we basically want to add everything else. So that means we should say, as long as I and j are not done. And how do we know if they're not done? Well, if they're less than the lists themselves, or the length of the list themselves. So we know we're not done processing. Okay, so this says right, but whatever. Okay, now, like I said, we should choose the leftmost point from either skyline. So let's say if the left one is smaller, then the right one, which happened right here, right? 2 is smaller than 3. Then, what should we do now? I'm trying to think. Well, okay. We should extract what this height thing is. At our current index, because that means we're now going to look at, since 2 is less than 3, we're going to look at this thing. We're going to extract the x coordinate, that is, so in this the 2, and the height, which in this case is the 10. And obviously we need to now assign this because that's our current height of the left tower, and increment I to make sure we get this like over here. So then we basically said like it's currently processed. We're done processing that. Okay, well, what if the right one is bigger? Or the right one is more left, so in this case smaller. Let's call this the right skyline. Or sorry, we're not calling it the right skyline. We're literally accessing that list and getting, in this case, once this 2 is here, we're getting this 3 and we're getting this 15. 3 being x and 15 being to h. And obviously we're going to assign our current height of the right building to be h, because that's the current thing, because we just processed it. Do j plus equals 1. Okay, but forgot about one case. What if the x coordinates are equal? What then should happen? Well, I'll tell you what should happen. So first, what we should do is extract both of them. H1, left skyline. Or sorry. Oh yeah, left skyline. Sorry, this should be I. And we're not gonna care about this value because we're just gonna, or since they're both the same, right? X, this will be x2, sure, whatever. But they're both the same, so we're just gonna throw it away. Right skyline, you have j, and that means we're just going to process this in one go. We're going to process both of them in one go. And I'm going to tell you right now why this makes sense. Okay, so let's look here. Let's say we had two buildings like this, right? If we had two buildings like this, we know for sure, like it's guaranteed that our output list will not contain duplicate x coordinate values, because that doesn't make sense, right? We always choose the highest one. So like whether our previous building is like right here, the Skyline will always choose like the highest one, because this doesn't give us any additional information. So basically we can process both of them. Okay, I think it'll make sense once I finish the code actually. Okay, now actually like putting into our list and processing it, like I said, we should keep track of this max, which is like the max are the current max between the two heights, similar to like, or actually I explained this, so I'm not gonna re-explain it. Basically, we should always add the max height of both of them and make sure it's distinct. And a simple way we can do that is this. Well, obviously, if there's nothing in this current list, then we should add it. Or if the last element that was just added, we can do that with -1, at its height position, if it's not the same, if it's not the same as like this thing that we're going to add right now, then we should then append it. Okay. Running out of space, but basically you can kind of tell like there'll be more code where if this condition is not satisfied, we should then like consider, okay, maybe, or this will probably always be the case, but that means like the left Skyline has some more, but the right Skyline has nothing, or the right Skyline has some more, but the left Skyline has nothing, in which case we should just add all of them. So that'll be another 2 while loops. Okay. And then finally, we would return our results after those 2 while loops. And that's actually all of it. So it's kind of a lot. Yeah, it's a lot, but just stick to the tips, right? The tips is you always want to, or sorry, for divide and conquer, you know what the steps are. There's 4. You know the tip is for it. You always want to think about how to recombine. If you find out how to recombine, you basically solve the question. Okay, now obviously you want to understand the question and make observations about it, because if you don't even solve the right question, then you don't solve the question, or you don't, then you're cooked. And then finally, you want to, as a kind of like an extension of finding out how to recombine, you want to go through a test case and see how you'd actually recombine it, like what like actual code you would write, in this case pseudocode. Okay, and then you would implement that. Okay, fine, I'll tell you guys the time complexity. Okay, so this would be O of 1. This would be O of 1. This would be T of n divided by 2. T of n divided by 2. This merge thing is O of n. Okay, so that means our T of n is, this doesn't really matter, is 2 Tn divided by 2. And you guys learned Master's theorem, so you guys are able to tell that this is n log n using Master's theorem. Okay, and I'm not going to prove it because I don't want